started this webinar series. Doug does such a great job running these month to month. Like Doug mentioned, my name is Peter and I work with the Colorado Climate Center at Colorado State University. And I just want to make sure that I mention I'm just the messenger today. So these webinars are really a big collaboration. It takes a lot of folks to put these together, get these right. So we have all kinds of state, federal, and even regional experts, including state climate offices from all over the NOAA Central region, as well as partners with NOAA NCEI, the Weather Service, NIDIS, as well as the USDA Climate Hub, the regional climate centers, and the National Drought Mitigation Center. Please do tune in next month for our next briefing as we take a peek at how we've started the spring season. That'll be given to us by Matt Siddle of Kansas State University, and he is the assistant state climatologist with the Kansas State Climate Office. If you want access to these webinars, you can sign up for them at drought.gov/events, or recordings of past webinars are available through both regional climate centers within our NOAA Central region. That includes the Midwest Regional Climate Center at Purdue, as well as the High Plains Regional Climate Center at University of Nebraska-Lincoln. All right, let's dive right into it. So we're going to start with a look at some of the recent weather conditions that we've experienced across the region, including 1 to 3 month and month-to-date temperature and precipitation conditions, as well as some relevant longer term climate conditions. We'll look at what's going on with snow this winter. We'll look at snowpack, snow depth, snow cover, even frost depths. We'll talk about soil moisture, and then we'll talk about our surface water supplies, rivers, lakes, and reservoirs. Then we'll get into some of the impacts that we've experienced. Some of you may have heard of the flooding that's gone on in Kentucky, as well as the Ohio River Valley. We'll talk about this recent cold air outbreak. Most of you joining, if you're joining with us from somewhere across the North Central region, probably have experienced some cold weather over the last week or even month to date. We'll look at the long-term drought situation, as long-term drought does persist across much of the region. And then we'll look at the outlook, starting with the next 2 weeks of weather, as well as looking at the longer-term spring outlook, including a look at the El Niño Southern Oscillation forecast, or another way to put that is just what's going on with El Niño and La Niña. And then we'll talk about what that means for our drought conditions, as well as river and stream conditions across the region going through the spring season. Let's start with those recent conditions, and we'll start with what we're all, or at least most of us, are feeling now. And that has been quite a bit of cold air over the month of February so far. So if we look across the region, on the left-hand side here, we are looking at departure from normal temperatures for the North Central region. All the areas in those cool colors, the greens, the blues, the purples, are areas where we've experienced below normal temperatures. You do see some warm colors in the southwest and southeast corners of the region. That's where temperatures have been above normal, but certainly most of us experiencing a cold snap right now. And there are parts of Montana and the Dakotas that have been over 20 degrees below normal for the month to date in terms of temperature. So a very cold start to February for most of us. Some areas of Montana even record cold. Now, if we look at precipitation on the right-hand side of the screen, you can see a mix here where the warmer colors here are representing lower than normal precipitation for the month of February to date. And the cool colors, especially the blues and purples, are where we see above normal precipitation for the month of February to date, including some areas such as Kentucky, where precipitation has been as much as 4 times the normal for the month of February to date. But really a nice mix across the region. Some dry conditions throughout the center of our region, and then certainly in the southeast and northwest corners, some much above normal precipitation conditions. If we back out to the month of January, we can see that we also had a cooler than normal January across most of the region. So we've got portions of Colorado, Kansas, Missouri, other states in the southern portion of our region experiencing temperatures as much as 4 to 6 or even 6 to 8 degrees below normal for the month of January in 2025. And then if we look at precipitation, we see that January was actually a drier than normal month for most of the region. There are some areas in Colorado, Montana, Wyoming, where we were above average for precipitation, but below normal for a lot of the region throughout the month of January. And you can see especially Minnesota and Wisconsin stand out there. Minnesota had its 9th driest January on record, and Wisconsin had its 3rd driest January on record. This is looking at the cold season through January, so November through January. And if we add in the influence of November and December, much of the region was warmer than normal over that time frame. So it's really been just in these last 2 months that we've been experiencing these cooler than normal winter conditions across the region. We really got a warmer than normal start to the cold season. And that especially shows up in areas like Minnesota, Wisconsin, and Iowa. Now, if we look at percent of normal precipitation, we do have quite a bit of the region that has been wetter than normal for the cold season through January. Certainly, if we were to include February in this, Kentucky would be way above normal. Areas like Kansas and Colorado, much above normal. Colorado, eastern Colorado in particular, this is largely due to November. But if we think about this balanced against longer term conditions, it's important to remember that for much of the north central region, the cold season is also the dry season. So we don't have the same average precipitation across much of the region in winter that we do in, say, spring and summer. And so it's hard to make up for long-term precipitation deficits throughout the course of a winter season. And so with that in mind, let's see here. This is the last 12 months for, let's see, the departure from normal temperature on the left-hand side. You can see over the last 12 months, we've been warmer than normal. But on the precipitation side, it looks like as I was just updating these, I grabbed the wrong graphic at the last minute. So I apologize for that. That will be updated in the final slide deck, but for much of the region, it has actually been drier than normal over the last 12 months. Particularly, much of the region had a drier than normal summer. Please pay no attention to that graphic. That's not going to show you that. And in fact, for the last 6 months, parts of the north central region experienced a top 10 warm August through January on record. Okay, let's get into snowfall, being that it's winter season. So here I just wanted to highlight a couple things, but overall we're looking here at the contiguous United States departures from normal snowfall for the cold season of 2024 into 2025. And here areas shaded in the orange and browner colors are areas where we have seen less snowfall than normal for the snowfall season to date. Areas where we've seen more snowfall are shaded in the purple, with the darker, more saturated purples showing much above normal snowfall. And I've highlighted a couple things on this graphic. First off, if we look at Minnesota, the Dakotas, Nebraska, Iowa, we certainly see that through much of the northern portion of our region, we're dealing with a bit of a snow drought, where there are parts of southern Minnesota, for instance, that have experienced a deficit of over 20 inches of snowfall for the snow season to date. And in some of these areas, that's over 50% of their normal snow accumulation for the snow season to date, or through February 19th, as this graphic is labeled. On the flip side of that, if you're to look at the UP in Michigan, or look at the sort of northwest portion of lower Michigan, kind of around Traverse City, that area, you can see areas with much above normal snowfall. And if we really stretch our region and look at northwestern Pennsylvania and upstate New York, we can see similar patches of much above normal snowfall. And I just wanted to mention that's due to some above average lake effect snow activity. And so some of the areas that benefit from lake effect snow have seen snowier than normal winters. And then finally, I just wanted to highlight my home state of Colorado, where we do see across much of the Eastern Plains, it has been a snowier than normal winter. And I mentioned this earlier, a lot of that really goes back to the conditions that we saw during November. This is a graphic showing just from a couple days ago, the anomaly in amount of snow on the ground, looking at the north central region. And areas in the yellows and oranges and even reds are areas where the snow depth on the ground is below normal for this time of year. Areas in the blues are where snow depth is above normal for this time of year. And so this just goes again back to show that the snow depth in the areas that are experiencing snow drought are below normal in areas like Minnesota, Wisconsin, and the Dakotas. And then you do have some areas in the more the southern portion of the region that are above normal. If you look at the western portion of the region, we'll talk more about snowpack in just a minute, but I just wanted to mention, looking at western Colorado and Wyoming, yes, there are areas where snow depth is below normal, but I should mention, just giving my home state a shout out, that ski conditions in many of our marquee ski areas are good right now. So in areas like Summit County or even Routt County up near where Steamboat Springs is, there's areas where the skiing's really good this time of year. And so don't let this kind of map deter you from coming and seeing Colorado. All right, this is a look at frost depths across the region. And we can see some areas in Minnesota where frost depths, and North Dakota as well, where frost depths are as much as 3 feet below the ground, in some cases even close to 3.5 or more feet. And the depth of frost can be important in the spring, as the whole kind of freeze-thaw cycle can be hard on foundations of buildings, particularly older buildings. When we were discussing this recently, one example that was given is that these greater frost depths in areas like the upper Midwest can lead to structural damage to things like cabins. So just something to keep an eye on, that even though it hasn't been a very snowy season, frost depths are actually greater. And in fact, these frost depths can be aided by a lower snow season, because fresh snow on the ground, or even just snowpack on the ground, acts as a blanket to soils, where it actually keeps soil temps closer to or above freezing below that snowy surface. This is a look at high elevation snowpack across the West US. So of course, if we're thinking about the north central region, we'll want to think mostly about the area sort of to the right-hand side of this graphic in Montana and Wyoming and Colorado. Overall, snowpack is near normal to a bit below normal in the upper Missouri River Basin, and then in the Platte River Basin, which of course feeds into the Missouri River further downstream, snowpack is currently running right about normal. So pretty decent conditions. We do have the Marias Basin in Montana showing up as an outlier with below normal snowpack for the snow season to date, but things are looking much better in this area than they did last year when we had a pretty severe snow drought. This is a look at snowpack accumulation throughout the snow season so far. And right now we're looking at the Platte River Basin. On the left-hand side, we're looking at the snowpack accumulation for the North Platte. On the right-hand side, we're looking at it for the South Platte. Now on these graphics, the horizontal axis is showing you the time of year, and the vertical axis is showing you the amount of snowpack on the ground in inches, or how much water is in that snow if you were to melt it down to liquid. And the red lines that you're seeing is the average throughout the course of the year. So you see that snowpack builds throughout the cold season, starting in late October, November, all the way through about the second week of April. And then weather gets too warm, sun angles get too high, and the snowpack melts out and becomes the water that we use in our lakes, streams, and reservoirs in the coming year. The shaded blue line, that's the current year. So the takeaway here on the left-hand side is that The North Platte is right about average. So after that last good storm we had this last week of February, things are right about average. And with the last decent storm, the South Platte is just a little bit above average. Now here we're looking at the Missouri River Basin, both the upper Missouri above Fort Peck and the kind of portion of the Missouri Basin after that from Fort Peck to Garrison. And on the left-hand side above Fort Peck, similar to the last graphic, the red line is showing us a normal year. The shaded blue line is showing us the current year. And then those sort of more thin blue line and green line are showing the maximum and minimum year on record. And as you can see for both the above Fort Peck graphic and Fort Peck to Garrison, we're kind of right in that normal range to a little bit below normal snowpack. This is a look at the Great Lakes and ice cover across the region. There's a few graphics to look at here. We've got our nice satellite image showing our ice on the Great Lakes, as well as snow cover and clouds in the lower right. The upper right is showing a time series of Great Lakes snow cover, where the red line is showing average cover throughout a given season, starting in November, going through June. And the black line is showing the current year. All the thinner blue lines are showing past years of data, where you can see that we're sort of in the middle of the distribution, but Great Lakes ice cover is a little bit below normal. With the cooler than average weather that we're experiencing now, I expect this to actually jump up probably a little bit, and then next week, when it gets replaced with warmer weather, we might actually reach our peak and start to see this go down a bit. But with some of the lower than normal ice across the Great Lakes, that can actually enhance lake effect snow, because for lake effect snow to work, you really need the liquid water surfaces of the lake exposed to this cooler air above the surface to help mix in the moisture that is necessary for lake effect snow. All right, this is a look at soil moisture across the region using the NASA Land Information Systems product. Again, this is showing the contiguous US, but we can focus in on the central region in kind of the upper central portion of this graphic. Areas in the yellows and tans and even orange and red are areas where soil moisture in the top 2 meters or about the top 6.5 feet is below normal, and then areas where it's shown in some shading of blue are above normal. So we do have this persistent soil drought across much of the region, including the High Plains and Great Lakes area. But then we also have areas like Kentucky, which unfortunately the soils were saturated prior to the big rainfall event that they experienced over the weekend. And so that exacerbated flooding conditions in that case. This is a look at stream flows across the region. So on the right-hand side, we're looking at 28-day average flows. The explanation of the colors is given in the key below, where the greens are normal stream flows, blues are above, and then the left-hand side is showing where we've had much above normal flows, and the black shaded triangles are where we've had rivers above flood stage, which you can certainly see around Kentucky, Ohio, southern Illinois, southern Indiana, where precipitation was quite extreme over the weekend. Now, if you're looking at the center of our region over the right-hand image, you see there's not a lot of measurements. And that's not because we don't measure stream flow in those areas. It's because it's been cold and those gauges are iced out. So we can't get a good accurate reading when the rivers and streams are iced over. This is just an example of showing the stream flow on the Ohio River near the Kentucky-Illinois border getting near flood stage. So here the horizontal axis shows you time from about February 12th through the current time, and then the purple line is a forecast forward. This graphic was pulled a couple days ago, so it's a little bit behind the current, but we did reach a moderate flood level there. All right, and then if we look at the US Drought Monitor on the left-hand side here, we're looking at current drought conditions from the US Drought Monitor map released this morning. The right-hand side is showing the changes over the last 12 weeks, where areas in greens are areas that have improved and areas in yellows are areas that have degraded. We can see that drought persists across much of the region due to longer term drier conditions and a hotter, drier than normal summer across much of the region that hasn't been fully made up for by conditions we've experienced this winter. Having said that, we're a little bit improved from where we were 12 weeks ago. There's 45% of our region in D1 or moderate drought or worse. That's down 11% from 56% 12 weeks ago, but it's actually up 20% from being at 25% this time last year. And that's owing to those warmer, hotter than normal summer and fall conditions that we experienced. All right, let's dive into some impacts. So first, this is just a radar image of the storm totals for, or a radar estimated storm total map for the big flooding event that occurred with the epicenter being over Western Kentucky over the weekend, some areas getting even up to 8 inches of rain. And this did lead to significant catastrophic flooding, resulting in thousands of swift water and car rescues, submerged buildings, road closures, and mudslides. Unfortunately, there have been 13 recorded fatalities as of 2 days ago when I put this slide together. And then this is just an image showing some of those impacts. This is showing a flooded football field in Pikesville, Kentucky, shared by James Knoll of NOAA. A couple additional impacts: 40,000 customers without power, 10 or 9,000 plus without water, 20,000 plus under a boil advisory. And then one more slide on the flooding in Kentucky. This is showing accumulated precipitation from a Kentucky mesonet station in Western Kentucky in Callaway County. So the horizontal axis here is time going back to mid-January. The vertical axis is accumulated precipitation. You can see there was a nearly 4-inch event near the end of January that really moistened those soils. Another event in the second week of February to keep the soils moist, and then that big dump of rain over the weekend that led to catastrophic flooding. I mentioned ice on the rivers. We've definitely seen that on the Missouri River as well as some of its tributaries. There have been ice jams on the Missouri River. This is a photo from the Memorial Bridge, Veterans Memorial Bridge over the Missouri River, taken from emergency management personnel over the weekend, I believe, near Sioux City, Iowa. And above these ice jams, the river tends to rise because the water can't flow beyond the ice jam. So that can lead to flooding concerns. However, as of when we talked to emergency management personnel this week, the concern is more not having the water available downstream of the jam, not having water being able to get through for folks to use. This is a map showing accumulated winter severity across the contiguous US. Again, we can focus in on the central region. And this uses data not only of temperature, but also data like when did the first snowfall occur, how many days has snow been on the ground, how much has snowfall accumulated. And if we look at the winter in aggregate, even though things have been quite cool recently, much of the region can be said to be experiencing a moderate to mild winter severity, especially around Minnesota, Iowa, and Wisconsin. Now, with the recent cold weather hitting when it has, we've kind of hit the start of calving season across the ranching and rangeland community. This is an example of a map showing risk of calving across North Dakota as of this morning, and the risk was extreme just due to the lower than normal temperatures that we're experiencing. And you can find these graphics for some other states. North Dakota looked the worst, but a number of places where the temperatures have been very cold, definitely a higher risk of heifers calving at this time. I've mentioned long-term drought several times. It doesn't just impact soils and streams, it also impacts lakes, it impacts ponds. This is just a graphic or a picture showing a low pond in northeast Indiana. taken recently, and we can certainly see this throughout quite a bit of the region with the carryover warmer and drier conditions from last summer and fall. All right, long-term drought. Here we are looking at departure from normal precipitation over the last 3 years. And so we can see that there are areas across Kansas, Nebraska, Missouri, and Iowa that have experienced as much of as a 20-inch precipitation deficit over the last 3 years. And so this is important because unless we get more good moisture going into the spring before the growing season starts in earnest, it could lead to extra agricultural impacts or even early agricultural drought impacts to start this growing season. So that's definitely something we want to keep an eye on going forward. All right, these are some more statewide impacts from kind of around the horn. I'm just keeping this slide so folks who want to look at specific states can look more closely at the slides once they're saved on the website. I'm not going to read these verbatim, but just some more specific impacts from states around the region. All right, with that, let's get into the outlook, and we will start with the next 7 days. So over the next 7 days, the cooler than normal or cold conditions that we are experiencing across the north central region are going to subside. They will give way to warmer than normal conditions across the region by Monday and Tuesday of next week. Many of us probably looking forward to that. I saw where I'm at in Colorado, we could see 60s early next week, certainly looking forward to it. As we get into the middle of next week, there is a low pressure system likely to develop across and whisk its way across the central US. That said, it does not look like it's going to wrap in cold Arctic air behind it in the same way that we're experiencing in the wake of the last storm. And it also looks like it's not going to be a huge moisture producer. So the graphic here is showing 7-day precipitation accumulation forecasts. And the areas in green across kind of the eastern portion of our region are areas where the next 7 days we're expecting to see 1/10 of an inch to 1/2 an inch of precipitation. So not very substantial moisture. Unfortunately, too, the areas that are expected to see the most moisture are areas that have already received way too much moisture over the last several weeks. Areas further to the west are likely to be dry over the next week. This is a look at the 8 to 14 day outlook from the Climate Prediction Center, and I want to take a little bit more time to explain these graphics because you're going to see a few of them over the next several slides. So we're looking at the temperature forecast on the left-hand side, the precipitation forecast on the right-hand side, and these are probabilistic forecasts. So the areas in blue, for instance, on the left-hand side are where we see an increased probability of below normal temperatures. Areas in the orange and red colors are where we see an increased probability of above normal temperatures. Now, just because an area is shaded in blue, in a darker blue than another area, doesn't mean it's going to be even more below normal than the more lightly shaded areas. It just means that there's more confidence in the forecast. The other thing that I should explain about these is that they're broken up into what we call statistical terciles. So if the forecast is expected to be in the lower third of the historical distribution, then that would be considered below normal. The upper third or above the 67th percentile would be considered above normal. In the middle, that's near normal. So that's what we're looking at here. And then if we look at precipitation, much of the north central region seeing near normal for the forecast for the 8 to 14 day outlook. And then the western half of the region maybe gets clipped by another storm and sees a slightly elevated probability of above normal precipitation. That could definitely go either way still at this point. Now, beyond this slide, I'm going to show a couple graphics like the one that you just saw, but for the month of March and for March, April, May. However, it's important to note that when we look at a longer term outlook, we're not thinking about our weather forecast models, which don't do well beyond 2 weeks out. We're basing these forecasts more on statistical relationships to slower moving parts of the Earth's climate system. And oftentimes we're referring to whether we're in El Nino or La Nina conditions. El Nino refers to warmer than normal sea surface temperatures across the eastern equatorial Pacific. La Nina refers to cooler than normal sea surface temperatures across that region. And the reason those sea surface temperature patterns are important is because they have somewhat predictable ripple effects on atmospheric patterns across the globe. And in our north central region, what La Nina, or cooler than normal sea surface temperatures, mean, which is what we're experiencing now, leads to, on average, an increased probability of above normal precipitation throughout the Great Lakes region and Ohio River Valley, and generally an increased probability of below normal precipitation in the southwest portion of the region, including Colorado and parts of Kansas, even perhaps Nebraska. So we're holding on to weak La Nina conditions right now. The graphic here is showing the percent chance by time frame of experiencing La Nina, blue, neutral, gray, or El Nino, red conditions. And if you look at the horizontal axis, you'll see these somewhat confusing labels like JFM, FMA. Those are referring to months. So JFM is January, February, March, FMA, February, March, April. You can kind of figure it out from there. Vertical axis shows the percent chance. So you see the big blue bar to the left, just showing we're in La Nina right now. As the spring progresses, La Nina may wane and we may give way to neutral conditions. It's unlikely that we'll have a rapid shift to El Nino in the coming months. And even if La Nina conditions do wane over the coming months, it is typical that we see kind of these carryover impacts or lagged La Nina effects for several weeks beyond when La Nina is officially over. So the March and April, May outlooks that I'm going to show now are largely based on the expectation that La Nina conditions will continue to dominate over the eastern equatorial Pacific, and that will carry over to the semi-predictable ripple effects that we expect on our atmosphere in the northern hemisphere. So here on the left-hand side, we're looking at the temperature outlook for the month of March, and on the right-hand side, we're looking at the precipitation outlook for the month of March. So for temperature, typically during La Nina, we do see an increased probability of below normal temperatures in the northwest portion of our region. You can see a little bit of that into Montana. And then throughout the southern and southeast portion of the country, an increased probability of above normal temperatures, mostly not bleeding into our region. So we actually have quite a bit of the region that sees an equal chance of above and below normal temperatures for the month of March. Precipitation, we see a little bit more of a clear footprint. So if we're looking at the upper Great Lakes region, we see an increased probability of above normal precipitation. For Colorado and parts of Kansas, we see a tilt towards below normal precipitation. Speaking specifically for Colorado, as we get into spring, we certainly do have plenty of La Ninas where we can get into near normal conditions or even slightly above normal conditions, but our really wet winters springs do tend to come during El Nino or during neutral conditions. La Nina doesn't tend to be as good for us. Now, if we think about the impacts of this, places like Minnesota, Wisconsin, Michigan could benefit from this above normal precipitation. So we hope we see it there, but areas like Kentucky, Southern Ohio, Southern Indiana, Southern Illinois, where we've already had above normal precipitation, that can be adding insult to injury. It can lead to more flooding conditions. It can lead to difficult planting conditions. So depending on where you are within that above normal conditions bullseye, it could be either good news or bad news based on what you've experienced so far. This is a look at March through May, and it's largely leaning on La Nina continuing to stick around, or if it doesn't, some of those lagged impacts sticking around. And so you do see a tilt towards below normal temperature in the northwest portion of our region. And then much like the March outlook, but even more strongly so, you see this increased tilt towards below normal precipitation, even expanding across more of our region, including more of Kansas and Nebraska. and Wyoming, and more confidence in Colorado. And then similar to the mark outlook, you see this increased probability of above normal precipitation persisting throughout the Great Lakes and Ohio River Valley. As far as the drought outlook is concerned, this is based on current conditions combined with the forecast for the coming months. This is also released by the CPC. Areas that are in the brown are areas that we are likely to see drought persist. That is not a guarantee, especially in the spring when for much of the region, precipitation can outpace evapotranspiration. And it's not unusual to see recovery in months like March and May. So because of the longer term drought conditions sticking around, you do see quite a bit of that drought persists label over the Dakotas, Nebraska, Wyoming, Minnesota, Iowa, but again, not a guarantee that that will be the case. Areas in yellow are areas that are not currently listed in drought by the US Drought Monitor, but drought development could occur based on what we're seeing in the seasonal forecast, and not surprising based on what I just showed, that that would include parts of Colorado and Kansas. And then areas like the Northern Great Lakes, Michigan, Wisconsin, we could see drought removal or even drought remain but improve. All right, this is showing the probability of river flooding across the region, including even parts of the Mississippi catchment to the south of our region. And here the areas labeled in green are where we don't see an elevated flooding risk over the spring season. Areas in yellow are where we see a greater than 50% chance of minor flooding, red 50% chance or more of moderate, and purple 50% or more of major flooding. So the river forecast centers themselves do give updates on these types of conditions if you want more information. The next update will be on Thursday, February 27th, the final on Thursday, March 13th. All right, so I will go ahead and wrap things up here just to summarize. Yes, it has been much cooler than normal across much of the region as of late, and much wetter than normal in the southeast portion of the region, including some flooding, even some severe flooding. That said, we do still have long-term drought persisting across the center portion of our north central region, and we do have an ongoing snow drought in areas like Minnesota, Iowa, and the Dakotas. As far as impacts, we've got flooding to our southeast, Kentucky, Ohio, southern Indiana, southern Illinois, cold weather leading to ice jams and riskier livestock conditions in the northern and northwestern portions of our region, and then long-term drought really centered over the center of our region, the Dakotas, Nebraska, Iowa, Minnesota. And then if we look at the outlook, how will things change? How may things change? In the short term, this cold air we're experiencing currently will be replaced by warmer than normal conditions. Longer term, a La Niña pattern is forecast to persist through the spring, perhaps weaken, but even if it does, there will likely be lagged impacts. And so along with that, we do see some areas in the Great Lakes and Ohio River Valley that could see above normal precipitation. And depending on what you've seen so far, that could be either good or bad news. In terms of drought, largely over the center of the region, drought likely to persist with the chance of things getting better just because it's spring. So we could see conditions improve markedly, but much of the region drought persists, and likely improvement in areas of the Great Lakes experiencing drought, likely development in areas like Colorado and Kansas. All right, that is all I will say. We've hopefully got time for some questions. Again, thank you so much for joining us today. Thank you, Doug, for putting this on. And Doug, if we have questions that we can tackle, let's take it away.
First of all, thank you, Peter, for that rousing talk. I hope people gain something from that, because there was a lot to say, like there is every month, and a lot of questions here to answer. Could you, I'm going to leave your slideshow up because there's a couple questions that may pertain back to what you showed. So could you go back to the very beginning when you showed last 30 days or even February temperatures? please?
Yes.
And let's go. Yeah, let's go to that one shows cold north, a little bit warmer south. Can you go to the next one?
Yep.
Yeah. Okay. So we had a question about, you know, and I've got this question before, so I want to sort of hit it a little bit hard here. This map showing the departure from normal temperatures on the left. It's basically saying that, yep, those temperatures down in Kansas, Colorado, Wyoming, Missouri, all the way to the East Coast probably, were departed from normal more than those up to the north, which actually were slightly above normal, where you see the yellow on the left-hand graphic. It's not saying, though, that Fargo was warmer than, let's say, Springfield, Missouri. What it is saying is that the departure from normal is positive. In other words, a little bit warmer than normal in Fargo and much colder than normal in Springfield, Missouri, well to the south, hundreds of miles to the south. Now, the other thing I want to say real quick is if you have a snow cover sort of in the southern part of this region, sometimes, especially at night, it can be colder down to the south than it is up to the north. But those are, I'd say, fleeting in terms of a few days that could happen. On average, if you measure it over a month or even a week, usually, those things sort of balance out, and it is colder in North Dakota. I don't know, 99% of the time than it ever is in Kansas or Missouri. But I guess not always. It doesn't have to be. But this is just showing anomalies. So it's not actually warmer to the north. All right, so that was one sort of question. You know, there are atmospheric patterns that can make things happen that are out of whack as well. But well, I guess we won't get into that. Would you please discuss some of the issues with the drought? The question was, is the drought monitor different than the soil moisture map? And if you go to your soil moisture map, maybe we'll talk about that for just a moment, Peter. I think you have one soil moisture map in this thing.
Yep, right there.
Yeah, it's showing really dark red around, let's say, Lake Michigan.
Yeah.
There's no doubt that some of those places have a deficit of moisture, but this is one graphic out of, we'll say, 50 that the people who in the drought monitor world, the authors of that, and the people in the state of Illinois look at when they determine how dry it actually is. So and sometimes we trust these maps and sometimes we don't. And it really depends on how a number of other conditions line up. This is modeled, so it's not a perfect estimate by any means, and certainly not for anybody's backyard. You wouldn't want to use this. This is a general depiction of dryness. Okay, so yeah, there's some dryness in that area, but it doesn't take into account how much snow is going to be melting, for example, coming from Lake Michigan that came off from lake effect snows a little later this year. It doesn't take into account a lot of things. But again, that's why it's different than the drought monitor, which takes into account a lot more information.
Yeah, that's a.
Yeah, go ahead.
Oh, sorry.
No, please.
I just wanted to say that those are all great points. I'd love to add to that a little bit. So I often run into this question when I talk with farmers and other folks across eastern Colorado is, especially in situations when our soil moisture models are showing worse conditions than the U.S. drought monitor, I'll get questions about, why does the U.S. drought monitor not show the same severity as the soil moisture model? Why is the drought monitor behind? It's not necessarily behind. Like Doug said, this is just showing one facet of drought, which is a very multifaceted hazard. And it can be frustrating if you're an agricultural producer when the drought monitor doesn't line up with a map like this, especially given that soil moisture is so critical for agricultural drought. And then I just wanted to also reiterate what Doug said about this is modeled. It's just one model. And sometimes with soil moisture models in particular, you can see some pretty stark variations among models in terms of the amount of soil moisture that you see. Whereas when we look at different data sources for things like temperature or even precipitation, they tend to align much more closely than with soil moisture. So that just adds a layer of uncertainty anytime that we try to look at soil moisture data on this kind of scale and apply it to a problem like the drought monitor.
Yep. Next question is: Are we going to go ENSO? Which they're probably meant. Are we going to go El Nino? And I don't know if that's what you meant or not. But my answer to that is we're currently in sort of a weak La Nina pattern. The atmosphere above the ocean and across, I'd say the northern hemisphere for the most part, is reacting like a La Nina though. And it'll take some time for us to shift. We'll shift gears in the ocean first, and then in the atmosphere. Let's say there's a month lag or something like that, to actually go into more of a neutral pattern, and less effect, if you will, of La Nina on North America as spring and summer prevail. One thing, and I think this is another question, is what is used to forecast La Nina and El Nino. It kind of leads into that question is, as you can see, here's the graphic sort of showing percentage chances of La Nina neutral and El Nino occurring, and those are 3-month periods at the bottom. That's what the acronym is. JFM is January, February, March, for example, the very first one. It kind of shows the progression, the weakening of La Nina being the blue, and then the strengthening of probability of being a neutral, not El Nino, not La Nina, sort of into at least early summer. We have a problem with predicting, or let's say a challenge is a better way to say it. We have a real challenge, let's say in April, May, and into June of predicting what's going to happen the next fall. We're going to make those predictions nonetheless, but we have something called what we call a spring barrier. And we mention this every year in that the predictability is very difficult during that time for what's going to happen sort of late summer into fall. Once we get a handle on that, as the summer sort of goes along, we'll make a better forecast as time goes on, of course, as we get closer and closer to it. So there's a whole bunch of stuff that goes into forecasting La Ninas and El Ninos. And a lot of it is just the monitoring aspect. What is going on in that ocean? That vast, vast pool of water out there right along the equator. Is it warming up? Is it warming up at depth? Or getting colder at depth? Is there something called a Kelvin wave coming across? I'm not going to go through everything because I don't know everything. But there's a whole bunch of different things that I'll say the experts watch to determine where we're going. But there are some difficulties too in certain parts of the year in terms of making those predictions.
Definitely. And I remember 2 years ago in 2023, we did have a rapid onset of El Nino conditions in the middle to late portion of spring, and that did have some pretty significant impacts on precipitation patterns across the country. What we're seeing right now from the experts, and like Doug, I don't know everything, but what we're seeing right now is that kind of an abrupt shift is unlikely in 2025.
Okay, we have a bunch of questions, and I got to go fast.
Okay, sorry.
Is there desertification in the U.S., expanding deserts like in the Sahara? I'm not the right guy to ask that question to. So I don't have an answer. What I would say, it's not quite like the Sahara in terms of the immense dryness that's doing. However, there are long-term trends that show that certain parts of the West, especially Western U.S., are becoming drier. Part of that is warmer temperatures evaporate more and can lead to aridification. I'm not going to say desertification, but I will say aridification of certain portions where temperatures are just too warm, and just even if precipitation stays exactly the same, you're getting a lot more evaporation. I'll leave it at that. I got to keep going.
Okay.
Peter. What is the forecast for the Mississippi River and impact to shipping restrictions? You know, right as of this section, at this moment, there aren't any, unless there's some ice or something, some ice flows or something I'm not aware of. There is plenty of water coming out of the Ohio for the foreseeable future. We'll see next fall when things could get critical. I'd say it could get critical in the summer too, but we don't know that right now. Really depends on what happens this spring, how much snow gets dumped, and all that other stuff from now until probably June and July. Then we'll have a much better handle on that. So I wouldn't say major issues at this point for the foreseeable future. Someone was saying minus 14 in a lot of places and rose to 7. Yes, warm air is on the way, no doubt about it. It's going to be weird, and it's going to be shocking and hopefully shockingly good to those of you partaking in those 60-degree temperatures early next week, we hope. And then curious if variability around the mean temperature is captured in any routine metrics. I know our average temperatures here in central Minnesota place us pretty close to historical normal. However, the variability around the mean feels really high this year. Yep. And the mix of some historic warm events with some very, very cold events. Yeah, so you're right. There's often a balance, and in this year, especially in Minnesota, you're not getting the snowpack that you normally would. So the coldness that you may normally experience is less, and your variability is probably a little bit higher than it would normally be, because that cold stays cold. Once you have a snowpack, you pretty much stay cold, especially in the more northern latitudes, which is more typical, which is this year is not. Soil moisture, Nebraska sandhills don't hold moisture as long as other areas. Maybe those Great Lakes soils are glacial till doesn't hold moisture on them either. Well, the great thing about the Nebraska sandhills is you're right. At the surface, they don't hold water, except every bit of water that falls in the sandhills goes down into the sand and does a great thing for base flow for the streams and rivers that come out of it. Like the Niobrara River is pretty stable when it comes to flow, even in the summertime, because of all that great sand that holds a lot of moisture in it. Whatever moisture does fall there. I'm going to run out of my voice here. No, is affected by it does not matter. Okay, which is more favorable for precipitation in Kansas, La Niña or El Nino? Oh boy, these are tough ones. Great question. I'm going to make a huge generalization here, but generally El Nino is better. All right. You can make a note to remember that, but don't hold me to that. So there is I don't think you touched on this, Peter. If you did, feel free to correct me. But La Nina springs, what we're going to come into here, a La Nina spring, there's a tendency for the high plains, especially in the southern to central high plains, which most of western Kansas at least is in, and eastern Colorado and western Nebraska south. There's a propensity to be dry, drier than normal. Now, I hope it's not true, and it's not a forecast. Although, Peter, go back to your forecast for March, April, May. You might show that there is a higher likelihood or slight enhancement of the probabilities for March, April, May. Yeah. Yeah, that one. Yeah. See that big below there in the four corners, sort of bleeding up into the high plains? That's pretty typical for a La Nina. So that's the forecast. So I guess I'll stick to it. Reasonably high probabilities there, especially in the Four Corners area. Oh boy, never. Are you able to forecast when spring? Jeepers creepers, these are $1 trillion questions. I cannot forecast when spring planting conditions are going to be favorable, but let me see. Let me check my phone real quick. No, someone did not chime in and tell me when spring planting when spring planting conditions will be favorable. Obviously what you want to look for are, when is it favorable to plant? Well, when it's not too wet, right? And so, in Kentucky right now, it's not looking great because it's so incredibly wet. Other places, I think we have to wait and see. Is probably the best way for me to say that. Tune in March. We'll have a better handle maybe on that and be able to speak a little more intelligently than I can about that kind of thing. thank you everybody who stayed on, and I hope you got something. Like I said, got something out of this. I appreciate you all coming, and thanks to Peter a lot for all your hard work. I know it was a lot, and we'll see you next month. Thank you very much.